Hey Algebra, guess what? It's me again. It is Wednesday, April 22nd, and here we go with our video of the week. So today, I've already introduced you on Friday to these two types of factoring, but of course we did it really quickly. We're going to start the video today with a few review problems just to make sure you got that factoring in your head. I'm going to have you read a few pages in the book, and then I am going to do several practice problems with you. Again, I would like you to take notes, and today you're going to be submitting your notes, okay? You probably won't have an assignment until actually tomorrow because I think this video is going to be kind of long. All right, so here we go. All right, here's review problem number 1. So what I want you to do is, of course, factor it completely. So go ahead, pause your video, factor it, and then come back and we'll go over it together. All right, so first of all, I hope you recognize there was a GCF, of course. So the GCF in this problem is actually 2. So I'm going to take a 2 out, and then I have 9a squared minus 9a minus 10. Now I'm going to try to factor the trinomial in the inside of the parentheses. I don't know if it'll factor, but I got to try. So the 2 comes along for the ride. 9a squared, of course I'm going to try 3a and a first, because 3a and 3a, because that's where my brain goes. And then 10, well, I've got the option of 5 and 2 and 10 and 1, so I'm just going to randomly pick 5 and 2. And because it's a negative on the end, I know I'm going to have a positive and a negative, so I'm just going to randomly put a positive and a negative. All right, well, so let's see how we did. So that's 15a, and that's negative 6a. And of course, the only thing I did wrong was my signs are wrong. So I'm going to switch, and I'm going to make this a minus and this a plus, and then I believe it works. All right, so there's number 1. All right, here's number 2. Again, factor completely, please. Pause the video, and then come back and check your work with mine when you're done. All right, so number 1, there is no GCF. I see 4 terms, so my brain straight goes to grouping. So I'm going to try to group these 2 and these 2. My first 2 terms have a common 2a squared. So when I take that out, I get an a plus 1 in the first parentheses. And then in the second group, I want to try to get a plus 1. So if I look, I think I can take a negative 1 out of my last 2 terms. And let's see if that works. That gives me negative a divided by negative 1 is a, and negative 1 divided by negative 1 is positive 1. Perfect, it works. So now my common factor is a plus 1. And then what I had left was 2a squared minus 1. And again, your answer could also be 2a squared minus 1 times a plus 1. All right. All right, here's problem number 3, negative 33p squared minus 6p plus 18p cubed. Again, pause the video, try to factor it completely, and then come back and check your answer with mine. All right, so on this problem, the first thing that I notice is I have a problem that's not in descending order, which I've told you before. I think you should always put it in descending order when it's a trinomial. So I'm going to rearrange it as 18p cubed. And when I say descending order, I don't really mean descending order. I'm sorry. I really mean put the biggest term in front, okay? Or actually, no, I do mean descending order. Okay, I'm losing my mind today. It's Saturday. My brain isn't really functioning. Sorry about that. Okay, so descending order. Here we go. All right. If I could rewind and edit that, I would. But, oh well, you guys know me. Sometimes my brain doesn't work very well. All right, so now if I look at this problem, I notice there is a common factor. And there's a common factor of a p and a 3. So I'm going to take a 3p out. And I get 6p squared minus 11p. And then minus 2p. No, not minus 2p. Oh my gosh, like I said, my brain is not working. I'm sure you all are laughing at me about right now. Okay, so here's what we have. So now I need to try to factor the trinomial in the inside. It may or may not factor. We'll find out. So I have 3p. Again, he comes along for the ride. 6p squared. Okay, I'm just going to try 3p and 2p. And then negative 2 on the end. Okay, so my brain first says there's no way I'm going to put 2 over here because then I would have a common factor. And we talked about that. We're not going to do that. So we're going to get rid of that. Sure we are. We're going to get rid of that. We're going to get rid of that. There we go. Okay, couldn't get rid of it. All right, so I know if I'm going to put the 2, I got to put it over here in this parentheses, which means I need a 1 there. And because it's a negative 2 on the end, I know I need a negative and a positive. Now again, I may have to switch those. All right, I'm ready to check. So this is negative 4p, and this is positive 3p. That gives me negative p. That didn't work, so I know that's never going to be the answer. All right, so I'm ready to start erasing. I'm going to erase the entire thing because who knows, I may have to change the entire problem. Well, maybe I won't change it. Okay, so if it doesn't work with 3 and 2, or at least I don't think it's going to work with 3 and 2, I'm going to go back and I'm going to change these to 6 and 1. And for some reason, it's not letting me erase. So I'm going to put a 6 over this 3. Sorry about that. And I'm going to put just a p. So there's just a p here. Okay? Let's just rewrite it. This is a rough problem. So 6p and p. Let's try that. And then again, negative 2. I'm not going to put a 2 in the first parentheses because that would give me a common factor. So I got to put the 2 over here and the 1 here. I'm going to randomly put a negative and a positive. All right, let's see what happens here. So I get negative p and I get positive 12p. Well, that gives me positive 11p. But I want negative 11p. So now I know I need to switch this. And I need to make this my minus. So my answer to this problem, I'm going to write it at the top so you can see it clearly, is 3p times 6p plus 1 times p minus 2. Obviously, I struggled with that one. I wonder how many of you did. Okay, here you go. Try this one. Try to factor it completely. Okay, so the first thing I notice is it's in descending order, but that first term has a negative in front. I don't like that negative. So I told you I factor out the 1, or negative 1. So that gives me 4t squared minus 3t plus 1. Okay, so now what I'm going to try to do is I'm going to try to factor that trinomial on the inside. So let's see here. What if I do 4t and t? And if I have a positive on the end and a negative in the middle, I know that I've got to do 2 negatives. I have no choice. So I got to do a negative and a negative, negative 1 and negative 1. So what's that give me? That gives me negative 1t and negative 4t. That gives me negative 5t, and I want negative 3t. Let's see. What's my other option here? Obviously 1. There's nothing else I can do with that. So the only other option I have is, what if I change this 4 and this t to 2t and 2t, because that's the only other way to get 4t squared. So let's see, what do I get here? So that gives me negative 2t, and that gives me negative 2t, that gives me negative 4t. Again, that's not negative 3t. So at that point, because I've tried all my possibilities, this answer is not prime, because remember, I took a GCF of negative 1 out. My final answer was actually right here when I took that negative 1 out. But I had to try to factor the trinomial because, of course, you can't look at it and decide whether or not it factors. All right, here we go, number 5. All right, go ahead and try this one. So let's see here. This one doesn't have a 1 in front, so this is where I can go back and use my little chart. So I want 2 numbers that multiply together to be positive 10 and add up to positive 8. Okay, so what are my possibilities here? So for 10, it's 1 and 10, or it's 10 and 1, or it's 5 and 2, or 2 and 5. And because it's all positive, I'm not going to try any negatives. Well, 1 and 10 is always going to give me 11. 10 and 1 is going to give me 11. 5 and 2 is going to give me 7. And 2 and 5 is going to give me 7. I can't get 8. So your answer to this problem was prime. Okay, so before we start our notes on factoring difference of squares and factoring perfect square trinomials, what I want you to do right now is stop and read pages 464 to 470. And I know how some of you are. You'll not only read it, but you'll take notes, which that's fine. Like I said, I'm not giving any assignment today. Today is just going to be taking notes and reading and submitting your notes. So if you'll stop the video and read those pages and then come back to me. All right, so before we actually start the new notes, I did this on Friday, but I'm going to do it again. So let's go back to our chart. What's all the ways of factoring we have right now? Well, first of all, we always start with, is there a GCF to pull out? Okay, after that, you start counting terms, okay? So you're either going to have 2 terms, 3 terms, or 4 or more terms. The number of terms determines how you're going to try to factor. So if you have 2 terms, you're going to learn today, right now there's only one way to factor it after a GCF, and that is difference of squares. We also talked about this on Friday. If you have 4 or more terms, there's only one option. It's grouping. And then 3 terms, we have trinomials. So we either have trinomials with a 1 in front, and if that's the case, that's where we use the chart to try to find 2 numbers that multiply together to be positive C and add up to be positive B. Or we have a trinomial that looks like this, where there's something in front of the x squared. When it's that, you just have to do guess and check. And then today we're going to talk about perfect square trinomials. And I told you this on Friday, and of course I'll tell you it again. It's nice to know, but you don't have to know it. It's meant to be kind of a shortcut. And now you guys always are worried about how much time it's going to take you on the test or the quiz, and this will be helpful. Okay? All right, here we go. All right, so I'm going to do backwards from the book. I like to do difference of perfect squares first. So I'm just going to write down a problem. All right, so again, I go back to my chart that I just made. So first thing I say to myself is there a GCF? Well, the answer is no. All right, second thing I say to myself is, how many terms are there? There's 2, so there's only one possibility. I'm going to look and see, is this a difference of 2 perfect squares? So this is how I tell myself if I have a difference of 2 perfect squares. First thing, is x squared a perfect square? Yes, it's x times x. Is 25 a perfect square? Yes, it's 5 times 5. And then the big question is it a difference? Well, difference means subtraction. So if it's subtraction, then the answer is yes. So because it met all my 3 criteria, I know that my answer is x plus 5 times x minus 5. Now, why is it this? Well, because if I only have 2 terms, that means I want a middle term that's going to cancel out. Well, 5x and negative 5x is the only way I'm going to get my middle terms to cancel out. All right, here's the second one. Okay, so let's see here. 4m squared minus 9. Okay, no GCF. 2 terms. I'm going to try factoring difference of 2 perfect squares. So first of all, I'm going to say to myself, self, is 4m squared a perfect square? Well, what times what is 4m squared? 2m. So the answer is yes. All right, 9. Is that a perfect square? I would hope by now that we know that yes, 9 is a perfect square. It's 3 times 3. And then, is it a difference? The answer is yes. So it met all 3 criteria, so I know my answer is 2m plus 3 and 2m minus 3. And of course, if this were the quiz, you would check it by foiling it. 2m times 2m is 4m squared. 3 times negative 3 is negative 9. And then if I do my middle terms, 6m and negative 6m cancel out. So yes, it works out. Okay, let's take a look at this one. 225x squared minus 36y squared. Okay, so if I look at this, I have to first ask myself, does it have a GCF? Well, guess what? Some people would jump right in and go, hey, you know what? 225x squared is 15x and 36y squared is 6y. And they would go ahead and say the answer is 15 plus 6y and 15x minus 6y, and they would be wrong. And the reason why is because, look, doesn't 15 and 6 have a common factor of 3? So what that means is, guess what? This problem has a GCF, and sometimes it sneaks by people, almost even snuck by me. So the first thing I need to recognize, I need to say to myself, hey, there's a common factor here, and it's 3. So I'm going to take a 3 out. So if I take 3 out, I know this is negative 12y squared. Let's see, 225 divided by 3. And of course, do I have a calculator right here by me? No. Okay, so it's 75x squared. Okay, so I have 3 times 75x squared minus 12y squared. Now, if I look at that problem, now I'm ready to say to myself, okay, is it the difference of two perfect squares? Well, yes, it's a difference, but is 75x squared a perfect square? There's nothing times itself is 75. Is 12 a perfect square? No, there's nothing times itself that is 12. So guess what? This one, once we take the common factor out, that is the answer. Now imagine if this problem was on the quiz and you didn't catch that, and you would have told me the answer was 15x plus 6y and 15x minus 6y. And guess what? Here's the problem. If you check that, it equals the top, but it's not right. It's not right because there's a GCF that you should have taken out, so you would have totally missed it if you did this. All right, here's the next one. 3x squared minus 48. All right, so is there a GCF? Because if I looked at this problem, first of all, and I didn't even think GCF, I'm sure there would be some people go, oh, neither one of those are perfect squares, it's prime. But no, you got to be careful. There's a GCF. The GCF is 3. So I take out 3 and I get this. And some people would say, oh, I'm done. But now what you have to do is you got to look at that binomial on the inside and see, is it the difference of two perfect squares? Well, it is a difference. X squared is x times x. 16 is 4 times 4. So yes, I can factor that binomial into x plus 4 and x minus 4. So my answer is really 3 times x plus 4 times x minus 4. Now, I have a funny feeling there are some people out there in listening land that would say, well, if this was on the quiz, how would I check it? Well, you would check it by foiling x plus 4 times x minus 4, which when you do that, you get x squared minus 16. And then you would multiply by that 3 on the outside, and you would get our original problem back. Okay? So the good news on this quiz, you can always go back and, re-multiply and make sure you get the original answer. The bad news is you got to catch that you factor everything completely and you take out the GCFs. All right, go ahead and try this one by yourself. Okay, did anybody fall for it? Did you write down 3x plus 7y times 3x minus 7y? If you did, shame, shame, shame. Because guess what? Yep, that's a perfect square. Yep, that's a perfect square, but it's not a difference. There is no GCF. There is nothing you can do to this problem. This problem is prime. I would love to know how many people I tricked. All right, here we go. Part 2 today, perfect square trinomials. Again, this is a part of the notes and part of the factoring that's nice to know, but it's not mandatory. So let's regress back. I did this on Friday, but I'm going to do it again. So in the multiplication section, if I gave you this problem and I told you to multiply it, I remember the first time I had some of you multiply this, the answer you got was 49x squared plus 9. Done. Well, we know now that's not the answer because technically this is 7x plus 3 times 7x plus 3. So you square the first term, 49x squared. You square the last term, that's positive 9. And then what I told you, the shortcut is you multiply the two terms, 21x, and you double it. So it's plus 42x. Now, I needed to give that refresher so that we can talk about factoring the other direction. All right, so let's start with this one. M squared plus 12m plus 36. Now, if this were on the quiz or the homework or whatever, this is just a normal trinomial with 1 in the front. So you could do this as I need two numbers that multiply together to be 36 and they add up to positive 12, okay? One way you could do it. Or some of you might look at this problem and go, hey, you know what? I see some perfect squares. Maybe I should try that shortcut she taught me. So the question is, well, what's the shortcut? Well, the first thing you say to yourself is m squared. Is it a perfect square? The answer is yes, m. Is positive 36 a perfect square? Yes, it's positive 6 times positive 6. Now, if I take those two terms and I multiply them, and then I double it, does it equal my middle term? The answer is yes. Okay, but what's that mean the answer is? The answer is just m plus 6 times m plus 6. Or, if you prefer, you can write it as m plus 6 squared. Okay, you would have gotten the same answer doing the chart way. It's just sometimes it's easy to have or nice to have a shortcut. All right, here's another one. So if I gave you this trinomial, first thing I'd say to myself is, okay, there is no GCF. All right, and then I could start guessing and checking. Or my brain can go, hey, I wonder if this is one of those special things that Ms. Leslie talked about. So let's see here, because I notice I've got some perfect squares. So 9x squared is 3x times 3x, and positive 4 is 2 times 2. If I multiply these two, that's 6x times 2. That's 12x. It equals the middle. So that means, oh, yeah, my answer is just 3x plus 2, the quantity squared. Now, if any of those things that we just said didn't happen, then you wouldn't do the perfect square trinomial. You would just factor it like a normal trinomial with guess and check. Okay, you try this one. Okay, so my brain says, all right, 4x squared, I know that that's 2x times 2x. 121, I know that's 11 times 11. If I multiply those two terms, that's 22x. And if I double it, that's 44x. Okay, so it all checks. So that means my answer is 2x plus 11 squared. Okay, go ahead and try this one, please. All right, so let's see, 25a squared. I know that that's 5a times 5a. 9b squared. I know that's 3b times 3b. But you know what I notice? I notice there's a negative in the middle. So I know that if this does work, I'm going to need a negative, okay? So if I multiply these two with the negative, I get negative 15ab. If I double it, that gives me negative 30ab. So on these, if it's not positive and a positive, you got to remember you need to make it a negative. So my answer is 5a minus 3b, the quantity squared. All right, try to factor this one completely. All right, so I'm guessing some of you, when you looked at this one, you probably thought Miss Leslie was losing her marbles because there's no perfect square roots at all. But the first thing you gotta do is say to yourself, hey, wait a minute, there's a common factor of 3. So I need to take my 3 out. And I get this. Okay. So then I look at it and I say, ooh, I've got some perfect squares. So I need to see if this actually factors into a perfect square trinomial. So 9x squared is 3x and positive 4 is 2. And I notice there's a negative there, so I need to make it this. So then when I multiply 3x times negative 2, that's negative 6x, but I have to double it. That's negative 12x. That's not negative 6x. So what that tells me is I know it's not 3x minus 2 times 3x minus 2. But that doesn't mean I'm done, because what I have to do is, if it's not a perfect square trinomial, maybe it factors a different way. So of course I got to try. So let's see here. So I'm going to try 3x and 3x. And I know I'm not going to try 2. What if I try 1 and 4? So what if I put minus 4 and minus 1? Well, let's see what's that give me. That gives me negative 12x, and that gives me negative 3x. That's negative 9x. So that didn't work. So what if I switch my 1 and my 4? And I make it 4, 1. So that's negative 3x and negative 12x, and I've got negative 15x. I'm getting worse. All right, well, of course, I can't say that I'm done yet, because what if it's not the 3x? Maybe I need to use a 1. I'm sorry, the 9 and the 1. So I got to try. 9x, nx, and then again, I can go back to either using 2 and 2 or 4 and 1. So let's start with negative 2 and negative 2. So that gives me negative 2x and negative 18x. Well, that's negative 20x, so that didn't work. All right, so let's switch it and let's try, whoops, got to have a pen here. What about negative 4 and negative 1? Well, that gives me negative 4x and negative 9x. That's going to be negative 13x. Nope. All right, I got one more thing I got to try. I don't have a choice. So what if I try to put the 4 here and the 1 here? Well, that's negative 1x and negative 36x. That doesn't work. So I've tried all my possibilities, and of course I got to try them all. My answer was right here, but notice how that could have tricked you because it looked like a perfect square trinomial, but it wasn't. So you got to be careful with stuff like that. All right, so we are done with notes today. It's definitely been a long one. So what you are going to do, your assignment is submit your notes today, and then tomorrow and Friday you'll start doing some practice, okay? And you know, my brain is wrapping around next week. I have a funny feeling, I can tell you right now. I think I'm going to switch the quiz to Thursday because I'm thinking maybe Wednesday we may need to do like an all-class review session. So I don't know. That's where my brain is going. So right now, don't freak out. I have a funny feeling the quiz will be next Thursday. What is that? The 30th, not the 29th. All right, so have a wonderful day. I'll talk to you later.